Okay, so welcome ulit sa ating channel. Ito na yung lesson 12 ng ating complex analysis, yung ating elementary function. So, saan pang elementary? Hindi. Meaning yung mga elementary function, yung mga yung exponential, yung logarithmic, yung dito na rin matatakil sila, tangent, sila hyperbolic, excuse me. Then, dito rin may matatopic or somewhere or some kailan. So, mga darating pang lesson, matatopic ko rin dito yung ating I raised to I. Paano mo i-evaluate yung I raised to I? Okay, so yung dating iniisip mo, sir, possible yun, yes, possible yun. Kasi sa number, pwede 2 raised to 2 eh. Okay, so dito, possible din yun. Okay, so start tayo dito. Siyempre, letter A, let's have the exponential function. Okay, z is equal to x plus iy, then define f of z is equal to e raised to z. So, naglagay ako ng blank dyan. Paano natin ginawa to? So, this is simply equal sa e raised to x plus iy, which is equal sa e raised to x, then e raised to iy. Then by Euler's formula, this is equal sa e raised to x cosine y plus I sin y. Okay, then this is equal sa e raised to x cosine y plus I e raised to x sin y. So ito yung pwede yung transformation niya. Okay, so in terms ng ating x plus iy. Okay, so next is let's have the properties of f of z is equal to e raised to z, o meaning na exponential function natin. So suppose or let z1 and z2 element ng complex number such that z1 is equal to a plus bi and z2 is equal to z plus di. So what is f of z1 times f of z2? So this is equal sa e raised to z1 multiplied by e raised to z2. Okay, and this is equal sa e raised to a plus bi multiplied by e raised to c plus di. Since similar ng base, ano pwedeng gawin? So, equal po ito sa e raised sa a plus bi plus c plus di. Then arrange konti, equal to sa e raised sa a plus c plus I b plus d, or simply e raised sa z1 plus z2. Okay, so mag-multiply ka ang dalawang complex ang dalawang exponential function. Ang gagawin mo lang, i-add yung kanyang exponent. Okay, as long as similar sila ng base. Although ang base natin lagi dito is e. Okay, so let's have number 2. Number 2 is f of z1 over f of z2. Okay, so paano siya? F of z1 is equal to f of z2 over f of z2 is equal to e raised to z1 over e raised to z2. And that is equal sa e raised sa a plus bi over e raised sa c plus di. Okay, and that is equal sa e raised sa a plus bi, okay, minus c plus di, and that is equal sa e raised sa a minus c plus I, then b minus d. Okay, so ganyan kasimple. Ang gagawin naman dito, i-subtract lang natin yung kanya exponent. So yung exponent naman, so subtract natin yung real part sa real part, imaginary part sa imaginary part. Ganun na kasimple. Okay, then number 3, f of z bar. Okay, so paano naman to? This is simply f of x minus iy. Tama? And that is simply equal sa e raised sa x minus iy. So this is equal sa e raised to x multiplied by e raised to negative iy, which is equal sa e raised to x, then cosine of negative y plus I sin of negative y. Okay, tandaan, cosine of negative y is cosine y. So this is equal sa e raised to x cosine y minus I sin y, which is equal sa e raised to x cosine y minus I e raised to x sin y. So dapat talaga kasama yung negative sa loob din. Okay, so ayan naman yung property pag naka-conjugate. Okay, next is f of z1 is equal to f of z2. Kailan mangyayari yan? So this is equivalent sa e raised to z1 equals sa e raised to z2, which is e raised to a plus bi is equal to e raised sa c plus di. So sabi niya, pag equal daw ng base tapos equal siya, nyari equal ng base tapos equal, ang ibig sabihin yan equal sa a plus bi. So this implies that a plus bi is equal to c plus di. Then by definition of equal complex number, this implies that a is equal to c and b is equal to d, o yung real part is equal to real part, imaginary part is equal to imaginary part. Ganoon naman natin masabi na equal yung dalawang exponential function natin. Okay, then number 5, the derivative of e raised to z with respect sa z is e raised to z. Okay, so no need to show na yan kasi wala naman talagang way para ma-show yan. Actually, si Cauchy-Riemann equation, nung ginawa ko siya, nung dinifferentiate ko siya using Cauchy-Riemann equation, lumabas na e raised to z pa rin siya. Okay, yun na yung way natin para ma-show siya. Okay, so let's have number 6. I'll check number 6. So, sabi, the modulus of e raised to z. Paano ba natin kukunin yung modulus ng e raised to z? Okay, so modulus ng e raised to z. Okay, so let's have the modulus of e raised to z. So, ulitin ko lang ha, paano ba natin kinuha si modulus? Naalala niyo yung ganito, no, sa polar form. So, if we have z raised to r equal to sa n to. R raised to n tas n theta. Na equivalent to sa r raised to n tapos cosine n theta plus I sin n theta. Dun sa ating De Moivre's theorem. Tapos, aware kayo na sa labas ng ating trigonometric form, sa labas na, yun lagi yung ating modulus. Kahit dun sa may pagre-raise, diba dun sa may pagkuha ng square, sa cube root, pansin mo, yung r raised to n or r raised to 1 over n nasa labas ng ating trigonometric form. So meaning, dito sa e raised to z, aware ka, na, diba sabi ang modulus ng e raised to z, so aware tayo na ito ay e raised to x, tapos cosine y plus I sin y, yung kanina transformation na ginawa ko. Okay, so basically, ang modulus natin ng e raised to z is equal to e raised to x lang. Okay, yung absolute value ng e raised to x. Okay, so ngayon, ang gagawin ko, tanggalin ko lang dyan yung ating z, o yung modulus. So, kunyari, kinuha ko yung ln nito. So, kunyari, kinuha ko yung ln. So, this is ln of e raised to z is equal to ln ng e raised to x. Tama. So, and therefore, this is equal sa z is equal to x. Kung tama ang aking pagkakasolve. Okay, wait. May napansin ako. Diba, ginawa ko modulus na nito. So, ang nangyari, si e raised to z, complex number na talaga siya. Okay, so itong part na to, erase natin to. So, dapat ito yun eh. Modulus of z is equal to e raised to x lang talaga. Kasi modulus na eh. Z, complex number naman talaga siya eh. So, ang nangyari, kinuha ko yung modulus niya. Ito yun. So, x tayo sa part na to ha. Huwag nyo kunin. So, pag ginawa tayo ln yan, so ano magiging ln yan? So, that is ln of modulus of z is equal to ln of e raised to x. And that is simply ln of z is equal to x. So, ito yung pinakasagot dyan. Okay, so, tandaan na, wag to. Okay, so sorry about that. Okay, next is about argument of e raised to z. Paano ba yung argument? I-represent natin dito ang module ang x. So, tignan na, ang complex number kasi, z is equal to x plus y. So, kung napapansin mo, yung z natin, napoform ko na meron siyang ln of z. Pag yung x pinalit ko doon. Ngayon, kulang na lang si y. Ngayon, si y naman, si argument of e raised to z. Si argument ng e raised to z is equal to, kukunin natin yung argument nito, o yung arg. Okay, arg of e raised to z is just yung ating principal argument of z plus 2n pi. Okay, for n is equal to 0, positive negative 1, positive negative 2, positive negative 3, and blah blah blah. Okay, so ano ibig sabihin ng argument of z? Ano pinagkaiba nung arg tapos malaking A? So, pag sinabi kong malaking A, argument, meaning siya yung argument sa uno, yung parang siya yung terminal side o yung terminal angle. So, parang ganito. Kunyari, ito yung angle. Ito yung ating, kunyari, ito yan. Okay, kunyari siya si 45 degrees. Okay, siya yung arg of C. Siya yung una. Ngayon, pag inikot ko yan, yung coterminal niya, meron sunod dyan. So, 360 plus 45, that's 405. Yun naman yung arg of C na maliit. Okay, kunyari, binalik ko, ni-reverse ko naman. Ay, pa rin, coterminal pa rin yun. Coterminal angle pa rin yun. Ayun yung pinagkaiba na. Ulit ha, yung pag maliit na arg, meaning, sila yung madami. So, kinukonsider yung revolution. Pag malaking arg, yung principal argument, yung ginagawa natin last time. Ayun yung pinagkaiba. Ha, tandaan yan. So, ngayon, itong part na to, i-represent naman natin to as y. So, this is just, so, ilit ko lang na theta is equal to arg of C. So, ito naman yung part na y. Y is equal to theta plus 2 and pi for n element ng integers para pinaka-safe natin. So, basically, yung mapuform ko na to, this is plus pi plus theta 2 and pi tapos meron naka-multiply na i sa labas for n element ng integers. Okay, so meron kasing kinalaman yan para sa susunod na gagawin natin. So, tandaan itong mga properties na to. Then, tandaan yung pinagkaiba ng capital A sa small a. Ulitin ko lang ha, capital A means yung 45 degrees. Yung small a, arg of C, sila yung mga 405 degrees. Nyari, i-reverse ko naman yung process, pag ganun. So, kahit ilang beses na bigot, basta isang revolution. Yun na yung ibig sabihin yan. Okay? So, let's have examples. Ngayon, naalala nyo, no? May nilagay kasi ako kanina. Ito. So, sabi ko, in z is equal to x plus iy. In terms of ating exponential function, kunyari exponential yung given. Ito yung representation niya. So, yung x is ln of z plus I, argument of z, or yung theta, yung principal argument plus 2 and pi for n element ng integers. Okay? So, ganyan natin nahanapin to. So, find the complex number z is equal to x plus iy for e raised to z is equal to 1 plus 1. So, meaning, yung e raised to z daw ay merong equivalent na complex number na which is x plus iy. So, ngayon, anong gagawin natin? Hahanapin natin sa x and y. So, note that from property number 7, we all know that x is equal to ln of modulus of z. Okay? So, what is modulus of z? So, ang z natin dito is 1 plus 1. So, note ang z natin dito is 1 plus I, sorry. Okay? So, ang modulus ng z is just simply square root of 2. Tama ba? That is square root ng 1 squared plus 1 squared, which is square root of 2. So, this is equal sa, x equal sa ln of square root of 2. Okay? Note na yung square root of 2. Pwedeng maging ganito. X is equal to ln ng 2 raised to 1 half, which is equal sa x raised to 1 half ln of 2. So, ito yung value ng ating x. Okay, next. Kunin naman natin yung argument o yung principal argument. Yung principal argument of z natin is equal to, that is quadrant 1, no? 1 plus y, 1 plus I, that is quadrant 1. So, that is only positive. Okay, so that is arctangent ng 1 over 1, which is equal sa anong angle yun? Since that is 45 degrees. Tama, that is 45 degrees. Or in radian, that is pi over 4. Okay, so mas ginagamit ni sir is radian. So kung hindi mo alam paano mag-convert, alamin mo na paano mag-convert ng degree to radian, radian to degree. Okay, so ang laging ginagamit ni sir dito ay pi, ay radian. Dito sa ating exponential, dito sa ating elementary function. So ano yung y? Value of y is equal to theta plus 2 and pi for n element of integers. Lagi nakalagay yan. So y is equal to pi over 4 plus 2 and pi for n element ng integers. Ito naman yung value of y. Okay, so therefore what is the z? What is our z? Z is equal to 1 half ln of 2 plus I multiplied by pi over 4 plus 2 n pi. Okay, then this is for n element of integers. So ito yung ating z. So ang sabi lang niya, pag e raised to something na ganito, ang sagot is 1 plus I. Yun lang naman sinasabi niya. Okay, so let's have number 2. So let's have e raised to z is equal to negative 2. Ganun ulit, hahanap tayo ng z is equal to x plus iy such that yung e raised to z is equal to negative 2. So ganun ulit, ano yung ating z? Z natin is negative 2. Modulus of z is equal to, that is, modulus of z is negative 2 squared plus 0 squared, that is 2, no? Positive 2. So this is positive 2. So therefore, x is equal to ln of 2. Okay, next, what is the argument or the principal argument? The principal argument of z, so nasan ba si negative 2? Si negative 2 is quadrantal. No? So, andito siya. Si negative 2 nandyan. Negative 1, then 0. So, meaning, yung degree niya is just 180 degrees or just pi. Tama. So, that is equal sa pi. Okay, so therefore, what is y? Y is equal to pi plus 2n pi. Tama. Then, this is for n element ng integers. Ito yung ating y. So, ano yung z? Z is equal to ln of 2 plus I times pi plus 2n pi for n element of integers. So, huwag kalimutan ilagay ito, yung condition sa dulo. Okay, so ganyan lang kasimple yung ating solving sa exponential function. So, hahanap ka lang representation niya in which makukuha natin yung kanyang parang equivalent complex number. Okay, so let's have letter B. So, from exponential, magpunta naman tayo sa logarithmic. So, if we set W is equal to f of z, where f of z is equal to e raised to z, then we have W is equal to e raised to z. Tama naman, no? So, ngayon, ang gagawin lang, ngayon, define the logarithm of z to be, tingnan nyo nangyari. Define the logarithm of z to be ln of z, modulus of z, plus I, theta plus 2n pi, o yung principal argument. For n is equal to 0 plus 1, 0, positive and negative 1, positive and negative 2, positive and negative 3, positive and negative 4, and so forth, or n element ng integers. And dito is principal argument of z. Yung theta is principal argument of t. So, meaning, ano ginagawa kanina? So, kanina, ang ginagawa, hinahanap kasi natin yung z, tama, na x plus iy. Nung ginamit natin ginamit natin yung process na alam ko. Yung alam ko yung x is equal to ganito, yung y equal to sa ganito, sa argument na ganito. So, ano napansin mo? Pag kinuha natin yung z kasi, ang gagawin natin, i-apply natin logarithm. Aware ka na yung exponential, siya ay biconditional kay logarithmic. Kumbaga, kunin ko yung logarithm niya, ito yun. Okay? So, meaning, ito siya. Ang logarithm daw ng z. Okay, so ngayon baka may nagtatanong, sir, anong logarithm yan? Base 10? Hindi ako sure kung ano yung base neto. Pero parang sabi wala siyang base eh. Okay, so ngayon ito yung pinagkaiba. Pag kinukuha mo yung logarithm ng isang complex number, dati sa real number ganito, no? Sa real number, hindi mo pwedeng kunin yung logarithm ng 0, ng negative 1, basta ng mga 0 tas negative numbers. Ang pwede mo lang kunin is 0.001. So, meaning positive real number lang yung pwedeng kunin. Dati, ngayon, sa logarithm ng complex number, pwede natin kunin yung logarithm ng negative 2, logarithm ng 0, logarithm ng negative 5. Andito lahat yan. Okay, kasi nga, lahat naman na real number complex eh. Okay, so dito, ito yung sasagot sa mga katanungan dati, ba't kaya hindi pwedeng kunin yung logarithm ng 0? At kaya hindi pwede kunin logarithm ng negative 3. Dito, pwede nang kunin kasi ito ay complex number. Ayun yung malaking pinagkaiba ni complex kay real. Si complex in-extend, kumbaga, okay, kung may kaya kang gawin, ako may mas kayang gawin kumpara sa'yo. Okay, pero sabi ko nga, in terms of math, sa pagkakaalam ko ngayon, mas marami talagang nagagawa kay real number pa. Si complex number lang, yung mga restriction kay real number, kaya namang gawin ni complex number. Ayun yung pinagkaiba nila. Okay, so ayun na ulit ha. So, ano yung definition of logarithm? Yung logarithm of z is just equal sa ln of z, ln of modulus of z plus I, theta plus 2n pi. Ayun lang yung formula. For n, element ng integers, and theta is the principal argument of z. Ngayon, if we let n equal to 1, tignan to ha. If we let n equal to 1, then the principal argument of z denoted by log of z. So, the principal logarithm, ito capital L. So, ulit pag capital L, ibig sabihin, i-let mo yung n is equal to 1. So, that is ln of z plus I theta. So, sorry, may kulang si sir dito. This is I theta plus 2 pi. Okay, so ganun kasimple. So, dato nga, tawag ko nga dito 20 log, tapos tapsilog. Kasi nga mas maliit to. Okay, so, tiko lang. Capital log, meaning n is equal to 1. Small l, meaning andun pa rin lahat ng n. Meaning, i-attach ko pa rin n element ng integers. So, tandaan yan, yung pinagkaiba nilang dalawa. Okay, so let's have example muna bago tayo mag-proceed sa mga properties nito. Examples, find the logarithm of z and the principal logarithm of z for the following. So, napakasimple lang nito. Dalawa yung formula lang gagamitin natin. So, importante, alam mong kunin si modulus sa si principal argument. So, una, let z is equal to negative 1 minus I square root of 3. Okay, so what is the modulus of z? So, the modulus of z dito is equal to square root of negative 1 squared plus negative square root of 3 raised to 2. Tama? And that is equivalent sa modulus of z is equal to 1 plus 3. So that is square root of 4 is 2. Okay? So may modulus na tayo. Next is the argument. What is the principal argument of z? So check natin. Anong quadrant siya? That is quadrant 3. Tama? So, since quadrant 3 siya, ano ang ating argument? So, ang argument niya is arctan ng y over x minus pi. Tama ba pag quadrant 3? So, that is arctan. So, arctangent ng negative square root of 3 over negative 1 minus pi or 180. Okay, so check natin. So, what is arctan ng square root of 3? Arctangent ng square root of 3. Okay, so note that the arctangent of square root of 3, kasi negative square root of 3 over negative 1 square root of 3, that is 60 minus pi. So minus pi. So minus pi is 56.8. Sorry, nagkamali. So minus pi, so this is 60 minus pi, no? So this is 60 minus pi. So, ano ba yung 60 in terms of ating ano? Okay, that is 1/3. Okay, so this is equivalent sa pi over 3 minus pi. Okay, so 1/3 minus pi is negative 2 pi over 3. Now, so this is negative 2 pi over 3. So, ito yung ating theta. Okay, so ito yung dalawang importante na kailangan. So, ano yung unang hahanapin? Yung logarithm, tapos yung principal logarithm. So, for letter A, log of z, o log of negative 1 minus I square root of 3 is equal to ln of 2, tama, plus I times negative 2 pi over 3 plus 2n pi for n element of integers. Ayun lang siya. So, ang basic. Next is letter B. The principal logarithm of negative 1 minus I square root of 3 is just, ililet ko lang to na 1. Okay, so this is ln of 2 plus I negative 2 pi over 3 plus 2 pi yan. Okay, then wala na yung n element of integers. So, this is simply ln of 2 plus I, then 2 pi plus negative 2 pi over 3 is pi over 3. Tama ba? Pi over 3. Check ko lang 2 minus 2/3. 4/3. Sorry. So that is 4 pi over 3. So ito yung ating principal logarithm. Okay, so ganun kasimple. Hanapin mo na yung modulus, hanapin mo yung principal argument, then apply natin yung formula. Okay, so number 2. If z is equal to 1 plus I, so ito, nadali na, no? So, alam ko na yung modulus nito eh. Ang ln of z natin dito is square root of 2. Ang argument niya is 45 or pi over 4. Tama, naalala nyo kanina, pi over 4. So, ano bang gagawin natin? So, since that is pi over 4, hanapin natin yung A. a logarithm of z o logarithm 1 plus I is equal to ln of square root of 2 is 1 half. No, that is 1 half ln of 2 plus I, then this is pi over 4 plus 2n pi theta, 2 pi theta. Sorry, pi pala to. That is 2n pi. 2 ay 2n pi. 2 ay 2n pi for n element of integers. Okay, so sorry, medyo nakakalitan. Ang dami ko na rin iniisip sa number. Okay, next is the principal logarithm ng 1 plus I is just equal sa 1 half ln of 2 plus I. Then this is pi over 4 plus 2 pi. So 2 pi plus pa. So 2 plus 1 over 4 yan, no? So that is 9 over 4. So this is equal sa 1 half ln of 2 plus I times 9 pi over 4. Ito yung kanyang principal logarithm. For n is equal to 1 kasi yan. Okay, so ganun siya kasimple. Ngayon, ito kasi yung medyo magiging kakaiba. Sir, paano po kung yung argument namin is may decimal? Ito lang ha, kunwari sir, yung argument namin may decimal. Anong gagawin mo pag yung argument mo decimal? Ang gagamitin mo, kunwari lang ha, if, lagay ko na dito. If arg of c is decimal, kunyari 2.3. Nari ganyan. Okay, so ang gagamitin mo formula, ganda na lang. So, ang log of c is equal to ln of modulus of z plus I, yung theta, plus 360 and for n element ng integers. Ayun yung gagamitin mo, 360 degrees. Okay, pag gano'n na, pag kunyari may decimal siya something, so basta may decimal, ang gawin mo na ito, 360n gamitin mo para maging kumbaga parang nakasunod, naka-align dun sa ating, kasi ang gara degree tapos pi, ganun yung nakalagay. Okay, tandaan yan ha. Okay, so let's have number 2. So if z is equal to negative 2, so ito nga yung tanong, no? Sir, possible yun? Logarithm negative number? Yes, possible to dito. Okay, so let's have modulus niya. Modulus na is 2, alam natin. Modulus na ito is positive 2. Ano argument nito? Sir, argument of negative 2 is 100 pi. Kasi nasolve yata natin kanina, sir. Okay, so daya ni sir, no? So hanapin natin si A. So A, this the logarithm of negative 2 is equal to ln of 2 plus I times pi plus 2 and pi for n element ng integers. So ang swerte ko, wala akong decimal na nasolve ngayon. Next is letter B. The logarithm, the principal logarithm of negative 2 is equal to ln of 2 plus I times pi plus 2 pi. Or simply this is ln of 2 plus 3 pi I. Okay, so yan na yung ating sagot. So daya ni sir, nakuha niya. So dito ulitin ko lang. Sa logarithm ng complex number, pwede natin kunin yung logarithm ng negative real number tapos yung 0. So kahit decimal pa yan, kaya natin kunin yan dito. Okay. Okay, so let's have the properties of logarithmic function. Okay, so let z1 and z2 element ng complex number. Okay, so we have property number 1, the logarithm of product is equal to the product of the sum of their logarithm. Tama ba? Logarithm of z1 times z2 is equal to logarithm of z1 plus logarithm of z2. Number 2, the logarithm of quotient is equal to the difference of their logarithm, which is logarithm of z1 over z2 is equal to logarithm of z1 minus logarithm of z2. Then z raised to n dito is equal to e raised to n log of c. Tama, kunyari gusto ko mag-raise. Kunyari 2 raised to 5. At 2 raised to 5. So gawin ko siyang, so kung gagawin ko siyang e raised to something, gagawin ko e raised to n log of c. Gagawin ko lang ganun. So yung n is yung number natin. Then dito po, kung gusto mo kunin yung nth root niya, ang nth root naman ng ating logarithm, kapag gusto mo kunin yung logarithm niya, is equal to exponential of 1 over n log of z. So, ito yung other formula para mahanap natin. Ito yung mga other formula natin. Magagamit yan. So, counterpart sa, z raised to, 2 plus 3i raised to 7. Gusto mo gamitin mo yan, okay lang. Z raised to 1 over n, fifth root of 3, gamitin mo yan, exponential ng 1 over n log of z. So, kung gusto mo lang. Kaso, syempre, mas mahaba kasi talaga siya, no? Okay, so let's have this number 1. So, gagawin ko lang is papakita sa inyo paano nangyari yan. Okay, so consider natin, gagawin ko, consider ko muna sa para siyang di ba, arg nito, kunin ko yung logarithm of z1 plus logarithm of z2. This is equal sa, so note na ito ay equal sa logarithm of z1 plus logarithm of z2. So, this is equal sa ln of z1 plus arg of z1 tapos i. Tama? So, sir, may i. Yes, may i yun. Kung naalala mo, no? Ano yung ibig sabihin ng arg of z1? Arg of c sub 1. Arg of c sub 1 mean yan yung theta, principal logarithm plus 2n pi. Okay, yun yung ibig sabihin ng arg of c1. Tawag ka lang dito, ha? Ibig sabihin ng arg of c1, arg of c is equal to principal argument plus 2n pi. Okay, then this is plus ln of z2 plus I arg of c sub 2. Okay, next, arrange lang natin konti. This is equivalent sa ln of z1 plus ln of z2 plus I, this is argument of z1 plus argument of z2. Okay, next, by property, ito yun, no? So, yung ln is similar sa logarithm. So, ang ln na yan is similar din sa product. So, this is equivalent sa ln of z1 times ln of z2 plus I, ito equivalent sa argument ng z1 multiply by argument of z2. So, hindi ko nabigay pa kasi yung property na yan. Okay, so therefore, this is equal sa logarithm of z1 multiplied by logarithm of z2. Okay, so similar siya doon. Okay, ulitin ko lang, ha, similar rin dalawang yan. So baka makita niyo yung proving yan. Arg of c1 plus arg of c2 is equal to arg of c1 times arg of c2. Okay, so isipin mo kung paano yan na-derive or what. Okay, so that's all for today. Yung mga susunod na topic natin is about branch cut and branch point, tapos yung derivative, tapos yung complex exponent. Okay, so doon ko na solve yung I raised to I. Okay, so kinat ko siya kasi kung isasama ko na medyo nakakalito na eh. Makakalito na si exponential, nakakalito pa si logarithm. So ayoko na isama dito si complex. So sa susunod na video, doon naman si complex exponent kasama si branch cut saka si branch point. Kasi gusto ko pang aralin ano yung meron doon. Okay, so that's all for this video. So hoping na nakikinig at nanonood ka at siyempre dapat naiintindihan mo. Thank you.